Alrighty, hello. I figured, since I was just talking about jet engines, it would be good to revisit modular engines. Since, they're kind of in the same vein, you build them yourself. And right here, I've just got a pretty basic display of engine components and what you can connect to them. So here we have, well actually, I'm going to think of it. That should be back here. Right there. Not here, because you don't connect it to the cylinders. So you can see here we've got, look, I got a little orange pointer block. So we got, right here we've got the crank, are they called crankshaft? I think they're called crankshaft, right? Yeah, just making sure they weren't called like a crankcase or something. We got crankshaft 1x1, 1x3, 3x3, and 5x5. Each one with its own corresponding things that you can attach. So 3x1s and 1x1s are the only one that you can connect a temperature sensor to. These little guys right here, they'll measure the temperature of the engine at any given moment. 1x1 cylinders right here, these little gray things. And this is what you can connect to them. As you can see, there's quite a few things. If we count, there's 1, 2, 3. Wait, hold on. I messed it up again. Clutches also connect to these. There we go. Clutches also connect to the crankshaft. Yeah, torque transfer. I was kind of rushing while I was setting this up, so don't worry about that. It means I need to remove that too, because those are actually the wrong size clutches. You need to have a 3x3, and you need to have a 5x5. There we go. So to connect to cylinders here, there's exhaust, air manifold, fuel manifold, a angled exhaust manifold, and a coolant manifold. Right here you can see this one. There's 5 separate things that you can attach. Only 4 of them are required at a time. Within the entire engine, I suppose. And on top of that, you also have the manifolds that allow you to connect things in different ways. So you can see this T here. This T would allow you to expand a 1 right there to, say, a connector like that. And now you have a fuel rail. Put a fuel intake on this side, and now you have a fuel rail that supplies equal fuel to all of the cylinders. Technically they do distribute on their own, but if, say, they're, you got a cylinder here, you now need a manifold to connect them, or 2 fuel intakes. So how you would go about doing this, we'll just take the basic one here. I always like to start at least a block off the ground so that we can attach a flywheel without breaking any blocks. And crankshafts can be clicked and dragged. They're the only modular engine component that you can do that with. So let's go 4 cylinders. 4 should be plenty. And we'll just come over here to my little part bank. And you can see I can't click and drag it. You can only click. So I think for this, I'll put them on either side. We'll leave the middle open for now. Now, of course, you can connect them to all 4 sides, but depending on the application, you may not want that many cylinders, and that's a-okay. So let's see. Well, we can hide this temperature sensor under here, just like that. And then, oh, it looks like I'm missing a piece. Don't have the drive belts. Those are a little important. Definitely want those. those also connect to the front here of the crankshaft. There we go. So these are not a required part because you can get the same results from external methods, but for this example they'll be okay. I'm just going to set this stuff over here because we may need it, we may not. Definitely will need a starter. So this one here that's like all black with a little bit of gray on the pulley is an engine starter, so we'll put that down there. You also have, whoops, shoot. Okay, there we go. You also have alternators, like so, which are essentially the opposite of a starter. And instead of taking electric to spin the engine, it takes rotational force from the engine and turns it into electricity. And then the fluid pump, as you can probably imagine, takes rotational energy from the engine and uses it to push fluid around. So a very common place for these is on top or on the side here. But since the fluid, if you see there, the fluid intake is on the back, I would suggest putting it on the top so that you can put a, well, I wouldn't suggest putting it on the top actually, I would suggest putting it on the side here. And then you would have to remove that cylinder. You can see that with this way, it'll push the fluid out the top, or you can flip it by using your mirroring tools instead of rotating. And now it comes out the bottom. You can also flip it so that it does it like that. You can also rotate it the other way. And you can also rotate it like that, which does the exact same thing. But you can never change where the in and the out is. So that's something to keep in mind. I don't like using them. They're clunky and they're not that great. And you can get the same effect from a, here, if we just switch to fluid instead, you can get the same effect from an impeller pump, just with the added benefit that you can put it wherever you want, so long as you have some RPS connected to it. We'll go back to that for now. But for the sake of argument and demonstration, I'll use a fluid pump. Modular engine fluid pump. And we will, unfortunately... Oh, hold on. Where is a coolant manifold? This thing here is a coolant manifold. Annoyingly, there is no way to know which side is in or out until you place it. So B is out, A is in. So if we want this to work, we somehow need to... Okay, I see. So we'll actually have to put... Hold on. We'll have to do this. Which is why I call them clunky, because you have to... This is what you have to do. And now you're missing an entire cylinder space. Plus it has to be connected down here. And coolant A is the coolant in. So somehow you have to get that coolant back around and into it. So we'll deal with it for now. And let's see, where should we put the coolant back in? Suppose if it's just for sake of argument, we can just sort of do that. Bam, just like that. So now when this starts up and does its thing, it will it'll start moving fluid around. And each of these have different things. So you have a temperature output, you have an RPS output. Most example engines, at least made by the Stormworks devs, they have it set up like this, which is fine, I would say, but I prefer to use my own thing, so we're going to do that. Now if we go over here and grab these manifold pieces, we can place them over top like so. and along the bottom as well. I like to do this just for looks. So even though this one won't really be doing anything, it'll be there. And we need the T pieces. And luckily having empty ends, like dead ends, doesn't actually harm anything. So like I could do this, and that'll just help with its looking, continuous. We do the same thing here. But you'll notice we don't have anything other than a straight, an angle, and a T, so you kind of have to sort of pick your poison. So I tend to just do this. That helps keep things distributed. Because technically you can have fuel going in both of these. Air can go in the top. This is like my favorite thing to do. Where you do this, and now you have a big old air intake. Just like so. Or you can take it off and you have triple intakes. Doesn't really matter. So now we can go over here, we can grab air intake. So we can do something like, whoop, not that. I do like some amount of symmetry, So we just, we can do 3 of them up here. And grab this. We can put both of these down here. And we'll grab some straight exhaust pieces. Oh, wait, hold on. I forgot to add a flywheel. Flywheels are important. Okay, let's check the flywheel on there. You can see flywheels take up a lot of space, and you can't put any cylinders past it unless you put another crankshaft on the other side, which looks silly. It looks silly to have a flywheel in the middle of an engine, so we just typically don't do that. You can see here, this is where that whole only having a T-piece becomes a bit of a pain. I really wish we had more pieces, but alas, it was not to be. I'll have to do a bit of manifold tomfoolery here. And now we can get our fuel rails connected. Should I have that like that? I think that should just be an angle. So you can see we now have a very limited access to things, but we could, of course, add on these T pieces here and swap this one around as well. But I think it looks better the other way. And now you can have... Actually, let's have all the intakes face the same way. Why not? And we can, throw our fuel rails on there. And we need an exhaust outlet. Just like so. And now you've got a very nice little engine right here. You will need a modular engine clutch to get that power to go anywheres. And now we have to have a way to control it. So for now, I'm going to go to fluid, and we're going to get the fluid tank set up. Go engine, grab my good old engine control unit microcontroller. Can grab that off the workshop if it pleases you. And we'll set an RPS limiter because these things get really loud, and we'll set it to 15. Turn that down to 0.5, so we got no turbochargers on here. I will get into those later if I feel like it. So fuel manifolds, connect that up. Air manifolds, connect that up. Clutch, connect those up. Starters, connect that up. And engine RPS, we'll connect it to the flywheel and not the crankshaft, because the flywheel is what holds on to the inertia, so we want the flywheel to be spinning at the right RPS. We don't really care about the crankshaft. They should be spinning at the same RPS anyways, but you know, just for safety's sake. And then we'll just slap a couple controls down here, and maybe a couple dials too. Let's see. 2 of them good? Let's go 2 of them. Do I need a third? Do I need a third for anything? I don't think so. We need a battery. I know infinite electric is turned on, but it's for case in point, you know. You would need a battery for this to get some electric energy in there. And now we just got to connect everything up. So you can go to ignition, U to throttle, engine RPM, or you can connect it to the flywheel, and we'll go with temperature right here. Sure, connect it to the backlights as well, just to get rid of those warning signs. And now we can spawn it. Oh, it's still dark from last time I was playing. There we go. I was looking at an epic sunset in a train. Recording I inevitably had to throw out because the audio quality was terrible. So we'll turn this up. Here it's starting. See, there it goes. You can see the air-fuel ratio. 14:1 is about what you want. I think engines will run with between, I believe it's 13:1 and 15:1. Anything above or below that, and you're not going to get full RPS range. I believe lower fuel ratios or richer, quote-unquote, fuel ratios will rev up faster, but will use more fuel, obviously. You can see it, we're at about half throttle. It's idling at about half of 15, which is what the RPS limiter is set to. You can see lots of useful outputs right there. And we can rev it up. See, we're now at about 15 RPS. It's not perfect, obviously, but I would rather it be not perfect than bouncing all over the place. We can turn it down to 0 and it'll drop to idle, slowly but surely. And we turn it off and it turns off. I guess it won't show me RPS on these parts, but yeah. And the alternator there, you can see its clutch pressure, which is 0. Turn it back on, it goes up to 1. You see that intermittency is my issue with it, because that intermittency doesn't allow much to happen. Like, it's very, very bad. So, now we've got the gist of it. Now it's time to get a little more complicated. Introducing converters. Yes? Yes, they are called converters. I made that up right there on the spot, and I didn't remember exactly what they were called, but yeah, they are converters. Glad I was right. So we can get rid of this, and we can slap a converter on there. So now we have this 1-to-1 engine, and we can connect it to a 3x3 or a 3x1 crankshaft. So you can see here, we can connect a 3x1 on there. This is also, say you had a 5x5, you can't put a temperature sensor on there, but with a 3-to-5, you can then attach one of these to the front, or somewheres in the engine, and then attach wherever it is. Oop, I missed. There it is. And you can attach temperature sensors to it. And like you might add it all the way around just for looks. Doesn't really change anything. But yeah. Ooh, what the? I don't know what happened there. But with this as well, right, we can get rid of this off the front. Let's tear this whole thing down to just the cylinders again. We'll go back to having all of these. So now let's put our flywheel back on the front. instead this time, just so we have a little more space. And we can grab a 3-to-1 converter here, which again doesn't allow us to put anything through here because it is, it's not 3x3, it's about, if you look, it's about an offset 2 wide, which makes it take up 3 blocks. And then using that, we can connect this thing on there instead. Now you'll see that we have access to 8 of these little slots instead of just 4. So the number of slots here goes for these here, which you can connect the alternator, starter, and fluid pumps to. The small one, the 1x1, has 4. The 3x3 has 8. And the 5x5 has 16. Wait, did I count that right? Hold on. 4, 8. No, 14. Sorry, I can't count. It would only be 16 if there were 4 on all 4 sides, but there isn't. There's 4 on the top and bottom, and 3 on the left and right. Or if you rotate it, right, you can rotate it like so. And now you have 4 on each side and 3 along the top. So using this, you can have an engine with, say, I don't know, maybe you want more fluid pumps, right? You could have fluid pump here, fluid pump there, 2 fluid pumps, pumping fluid to 1 output, and it wouldn't change the intermittency. They'll be the same intermittency, but you'll just have double the flow. Or, you can have twice as many starters, twice as many alternators, all that jazz. There is also another way that you can start an engine, which also has to do with a clutch. So you can connect a clutch there. Let's say we'll grab a T-piece here, grab a clutch, like so, and I don't know, grab like an electric motor or something. And I will grab my handy dandy toggle to number. So typically I would actually have this on the front here, and then the output on the back, but since we're kind of constrained for space, we'll just do this. Then we'll set both of you to 1. Wait, hold on. You don't need to be like that. You can be connected to that. Nope, not that. That one. And throttle can be connected to throttle. And we'll just, I don't know. Sure, do that. Just so that we don't have exclamation marks. And now you'll see, oh, hold on. Let me connect some electrics up here. Need a battery. I got rid of my battery. I shouldn't have done that. Ah, well, it is what it is. Spawn that in. So you'll see now, push the button, and it starts spinning up the crankshaft. Then it would deactivate at 4 because most of these engines start running at 4 RPS. So I like to keep them idling at about 5 so that they don't stall out. So you can see it's spinning, nothing's happening because obviously there's no fuel or anything. I can turn on infinite fuel. Nope, you need to have the things on it. Hold on. So yeah, good to note is that you still have to have the manifolds on it, even if you have infinite fuel turned on, because they don't run without it. And we'll just check an exhaust on there just to be safe. Just like so. Now we can spawn it. You'll notice it doesn't just start. You do have to spin it. Oh, Silly me. I need to connect the throttles. Okay, let's connect. Where is it? There it is. We need to connect the air and the fuel. And we need to turn you down. Oh, and we want to turn you on. Turn you down to 20. It sounds really low still, isn't it? Let's turn that back up a touch. So, yep. You can hear it ticking slightly. I'll get really close to it. You can see the throttle there. Of course, with that flywheel, it takes a bit of time to rev down. And now I think it might be a good idea to just show off one last thing while we're here. And that is to do with these. So I'm just going to make a really, really simple system of things here. And we're going to have a 5x5 crankshaft with a converter to a 3x3 with a converter to a 1x1. And then we'll have a 1x1 crankshaft on the front there. And we'll grab a cylinder. Get rid of that extra thing that I accidentally put there. Put that there. Put that on there. Put you on there. For God's sakes. Ah, jeez. Keep forgetting to connect things. There we go. There we go. Now she's spinning up. Yeah, it certainly sounds goofy, but as you can see... Shut up. As you can see, we got 60 here, 60 there, and 60 there. All the exact same RPS, even though they are different sizes. So, turn that off. Yeah, really loud, really annoying. So that's why I kind of developed my own RPS limiter, because, yeah, 60 RPS is really loud. And also generates a boatload of heat. So maybe it'd actually be good to show what happens when an engine overheats. Seems like an important thing to cover. Turn you down to 10%. You'll see it has a manifold temperature. You'll notice as its RPS increases, that temperature also increases proportionally and at a proportional speed. Of course, the higher the load, the higher the RPS, the higher the heat generated. To an extent, RPS is the main thing that generates heat, though. You can see it's at 60, and it's at it's either 110 or 115 that it blows up. I think it's 110. 110, and then it blows up and skyrockets from there because it's on fire. Which is why there's this engine overheating thing that you can turn on and off. You can see produces plenty of torque. And these 5x5 cylinders create immense amounts of torque. But they also generate a lot of heat. Oh, it's 105. Or not? No, it is 115. These ones heated up first because they were, I don't know. But you can see it all blew up. It's all on fire now. Everything is terrible. And also batteries also catch on fire when they break. Electric motors don't. Microcontrollers and buttons don't. Generators don't. But running cylinder, oh, even non-running cylinders do. So yeah, you can see a lot of stuff in these engines catch fire. Clutches don't. So yeah. There is one last thing I want to touch on, but it takes a little bit of time to get set up. So I will be right back when that is done. Alrighty. Now, this might not look like much yet, but you might recognize its layout if you've looked at my workshop ever. This is how we make shapes that are not at 90-degree angles. Say we wanted to make a V shape, as I've done here. So when I spawn it in, oh, uh-oh. Oh, it's because I... Hold up. Why aren't you rotating? What did I miss? Right. There we go. Okay, that should fix that. Typically you would just have a constant number. Oh, looks like it's hitting the bottom there. Whoops. Okay, let's just cut a hole here so it can rotate itself. There we go. Boom. That's a V right there. And if you'll look, oh, that is connected the wrong direction. I did not even notice that. I miss things sometimes when I'm building. There we go. That'll fix that. I completely neglected the fact that that was a modular clutch connected to a non-modular thing. There you go. You can see we have 153 Newton meters of torque, which is not much for an engine of this size. But RPS goes up. Kind of sounds like a lawnmower. Sometimes weird things happen with the RPS on really low loads, but as you can see, transferring RPS from this V shape, and you can do this with whatever layout you want, right? You can make a 5x5 engine into a V like this, but you would just need a hell of a lot of space for those things to rotate. Same with the 3x3s. These ones are a little more difficult to work with because of their shape. You can put, 8 cylinders around, but if you've already got space to fit those in there, you might as well have just put 3 of those in parallel, or 2 of them in parallel, or whatever, and you'd be able to get more cylinders in there. So it's certainly a different sort of building experience. But this is definitely my favorite thing that I've done. We got our big block V8 over here. It's coming down to idle, you can see. You can turn it off and it rotates back, so typically I would have it set to a constant signal. So instead of like a toggle to number here, I would just have search up constant. So I just have like a constant number stuck to it with a value of, for this one, it was 0.5. About half a turn gets you 45 degrees, and you check the arrow here. So see, my arrow is positive to anti-clockwise or counterclockwise, and this was built to be rotated counterclockwise, so it kind of worked out. Unintentionally, but that's how it worked out. And then when we spawn it now, you'll notice by the time we get over there, it's already rotated. No fun watching it rotate over here. And of course it starts up and all that jazz. I suppose that does look a little strange, so you could put another one on all four sides just to make it, you know, match, but or you could put one on that side just so it kind of matches. And you can see right here is the exhaust down there on the bottom. And right there is fuel. On the front here is air. And if you look down here on each side, we have coolant manifolds. And using this, you can also create like a proper X layout by having the same thing but with all four banks of cylinders filled in. You can see here I just filled it in with manifolds to kind of complete the shape and hide a temperature sensor in there. You can see even without cooling, its temperature is barely increasing. If we start it up, you can see it's running, but it doesn't actually produce all that much heat while it's idling. It's got really low RPS and really low heat generation. And you'll notice if we rev it up, it starts to gain heat pretty quickly. Then we drop it, and it drops, maybe? I don't know. I don't know exactly if it'll drop back down from that low of a temperature, but it does have ambient cooling, obviously, but it's not super strong, so it is always recommended to have cooling systems installed on these. The only thing would be that that's not actually all that pretty because they both come out the same side. Come to think of it, that wouldn't work, would it? Now that needs to be connected directly to the cylinder, because otherwise it starts to leak coolant, which I think is just because it kind of goes like, hey, I'm connected to every other input, and then it kind of just makes a mess. So yeah, you probably do something like that, and down on this cylinder here, do something like that. Coolant B. Oh shoot, they're both coolant B. We don't want that. There we go. Coolant A and coolant B. And then we can remove U. And then we can slot our temperature sensors in these two gaps here. Remove that one there. And, yeah, you can design it however you want. This is just kind of how I do it. Try and keep it somewhat clean. And, you can set it up however you want, but you just have to remember which way it's going to rotate. I like to use red on the top here for the air. So it kind of looks like an air manifold or an intake manifold. Then I use something like, the dark gray on the bottom to create kind of like an engine block. Something like that, you know? Angled there, angle there, then fill in the space. And you can put the where is it? Do I have any left? I don't have any left on here. Grab the T piece, make it that dark gray color. Is that the right dark gray? Yes. Anyway, you can also put one right here like that. You always have to remember orientation so that you have proper symmetry when it flips upright. So if you do something like that, you could have fuel in the front ones and exhaust out the back ones. Or you can move the exhaust ones, say, down here, like so, and have a fuel one right here, like that. And you would just have to remember that here at the end, it would have to chink out like that. But yeah, these are certainly not easy things to work with. Clearly, it's hard to work on 45 degrees with 90-degree items. But it is possible, and it can look pretty cool. Definitely worth the effort, I will say. But yeah, they're fun things to experiment with, especially once you get the hang of it. And I don't think there's really, well, I did say I was going to go over turbochargers, didn't I? So for that, why don't we use this one? We'll do something a little different here. Can I click and drag these ones? I can. Okay. I wasn't sure because of the way they are. We'll grab, yeah, let's go 4 tall. 4 tall should be good. And we'll get rid of you. And we'll make sure to have this one at the ready this time, instead of having to go find it later. So here it's very important to use these in order to connect all the cylinders together, because cylinders only connect in rows. So these 3 in a row right here would connect, but they wouldn't connect around that 90 degree. Lots of design choices you can make. I tend to go with whatever looks cleanest, at least in my eyes. So that's why I put them on all of them all the way around. You don't have to, but it looks better to me that way. So that's why I do it. You can't put these in here. They have to be connected to those or something solid, quote unquote. So these don't count. That doesn't count. That does, that does, that does. The ground doesn't, but the side of the microcontroller does. You can see, it won't let me place it. And we'll just come around back here. And we'll grab some angles. Boom, boom, boom. Oh, I'm missing one. There we go. We got all 4 corners done. And then here on the front, we will need a straight for one thing, like so. And we'll need the coolant manifolds. There they are. So we'll have ins and outs. Oh, look at that. I actually got it right. So we don't really care about this right now. We'll just, I don't know, leave it as is. And here we're going to have air intakes going around like so. I'm not sure what to put on those, so we'll just make them... Oh, actually, I got an idea. Do a bit of that. So if we do this, then I'll get a nice color here. Let's get like a light blue for this part. And then we can do a bit of this, and we'll switch to, whoops, fluid. And we will grab some impeller pumps. So this is how you can make a forced induction. We'll have it on the back here as well. Oh, I'd like those to face the same direction. So as you can see, we have hexa turbos. We got 6 of them. We got hex turbo set up. Not quad turbo, we got hex turbo. We got more turbos than a Bugatti. Look at us go. So currently I don't have any better way to power these than with an electric motor, just because the nature of how my microcontroller works. There might be a better way, but I just kind of don't try too hard. Though I do suppose that my aircraft engines do have a way for that. When you turn on like a power boost, it turns on the turbos, they're forced induction, and then increases fuel richness, but it's really complicated, and I don't feel like building that all over again and for it to happen automatically, so we're going to just do our thing here. So you can see that's why this is always set to 0.8, because that's for turbos, or forced induction, whatever you want to call it. If you don't believe these are turbos, that's fine. I call them turbos because they're impeller pumps. What am I looking for? Gearbox. These don't need a ton of RPS to function properly. They need torque mostly. So we will grab some small electric motors here, and we will connect them to something. I think I usually connect them to the fuel manifolds one. Then, you know, we can connect that up, whatever, doesn't really matter. Kind of wish I hadn't deleted that battery over there. Just slap like a giant battery over here that I can connect things to. There we go. So now that'll work. And we need some intakes. We'll grab air filters. And we need to grab the exhaust, just to have it there. Now we've got this very strange looking square of stuff. And it usually takes a little bit, well, a few tries, I should say. It usually takes a few tries to get this thing running, because, you know, every setup will be different. It's not like there's a perfect solution to figuring out what fuel richness you need to run. So I typically leave it high and then lower it from there. And that's all connected yet. So we'll spawn this. So we'll see if it starts right off the bat. Okay, it's running. Right, infinite fuel is on, so it's going to run regardless. We need to turn off. Oh, it doesn't have any fuel intake, does it? I'm just now noticing this. There we go. Okay, now we'll have a properly functioning engine. Hopefully, assuming we've done everything right. Ooh, she looks a little low. Or a little rich, I should say. Oh, it is running. I forgot to connect the RPS, that's why it did that. RPS. There we go. Okay, let's try that again. So you can see that because of the way these are, they now are pulling a constant amount. Yeah, let's just go check on all the cylinders. If they're all doing alright. You can see its temperature is going relatively high. You can see that it is definitely still running a little bit on the rich side when you get to low RPS, low RPM. It's running a little on the rich side, which is of course something you could probably fix with like a extra PID controller connected to the air and the fuel outputs instead of it just being one combined output. So you could probably, there's probably like, you know, more advanced ways you could make this work, but I think it's cool that you can just do that, you know. And you can see as it drops the fuel throttle, the air-fuel mixture drops in richness again. Or, sorry, it increases in richness. I'm reading the number backwards again. You can see how it's not quite at the proper richness, so it'll need some fine-tuning. But minus 20 stoichiometric is pretty typical for my forced induction ones, because you're forcing air into it. And if we turn on, you know, infinite fuel, it goes back to normal. And, you know, it continues to struggle to rev up because it's spinning a giant generator. But yeah, so that's how you do forced induction, which of course would work with any type of mechanical powered fluid pump, of which there are all of 2. It will not work with a large fluid pump because of, well, actually it might work with a large fluid pump, but it won't work with this one because it's intermittent. And that's kind of, that's it. Actually, it isn't it? There's like, you can have like big turbos, you know. Just the only thing is that they would be sitting in here kind of weird. So like you could technically replace the 3 of those with probably one big one. Right, you could probably place it like, oh, the other 2 are in the way. And so you could place it like right there and just have those connected to each other. Then you can have 2 big turbos. Because like, doesn't that just look cool? Yeah, getting a little off track here, but it's something that I had said at the beginning that I was going to touch on, so I figured that I probably should. And now I have. Here, I got a faster way to clear all this out. Bam, gone. And let's see, am I missing anything? We went over how to build it. We went over building. We went over, let's see, we went over building. We went over flywheels. Yeah. We went over V's. We went over force induction. And I think we've done, yeah, we went over starting with using the modular engine starters, using non-modular engine starters. Just thinking if I'm missing anything. I don't think I'm missing anything, other than obviously you need cooling. None of these examples ran long enough. If we actually just load the presets here, there's a preset for engines. You can see you have the prefab engines here, being like a lawnmower thing, an aircraft like V12, I think? No, V10. Aircraft V10 there. A marine 3-cylinder here. You can tell there's 3 piston heads there. And then we got the jet turbines, obviously, right there. Then you got a 20-cylinder 1x1 engine here, 4-cylinder 3x3, and a 2-cylinder 5x5. Each of them, of course, with their own cooling. So we can spawn this in, and we can take a look at the prefab example that comes with Stormworks. You can see a throttle of 1. You can turn your throttle down. This is where you can see the function, where that has x over 2, or 0.5x, which goes to the fuel intake. You can, turn it on. You can see here that they use a switch box. Come on, you. Come on, you. There it goes. Oh, I see, because this is connected to a big generator. You can tell a lot about their power output by the gearing here. So this one has a 3-to-1 and a 1-to-3 and a 1-to... Oh, maybe that's a 2-to-3, possibly? I don't know, I'd have to look. So we can turn all of these things on. Oops. See, there it goes. See this one here, looks like it has a 3-to-2 reduction. Yep, that looks like a 3-to-2 reduction there. You can see this one has a rogue wave. Looks to be also that looks to be a 5-to-6 ratio there. See, this one here has a 2-to-3, and then what is that? 2-to-3, and then maybe another 2-to-3, possibly double 2-to-3s. You can see this one idles at 6, this one idles at 9, and this one idles at 9. We're not going to touch the jet because it's loud, and we already touched on jets in a previous little walkthrough example thing. See, are you running? Yep, you're running, so you have, looks to be about the same. You come to idle at about the same, I believe. Correct? Looks like it. So let's just check on the outputs here. You give an output of 46 for a small engine. You have an output of 131, but it's slightly larger, about twice the size of its prefab counterpart, or non-modular counterpart, if you will. This one here is not running. Turn that on. See, this one is now running. You can see it produces quite a bit of power, but again, twice the size, a decent bit more power. You can see that this one's only making 130, whereas its medium, quote-unquote, counterpart over here, which is twice the size, is making about 6 times the output, while idling at the exact same RPS. And then this one here, we already saw this one a little bit ago. You can see this one is making quite a bit of power, but again, about twice the size. Now these ones are a little more similar in size actually. But you can see this one here is making 312, and this one is making 1809. So a bit of a difference, but again, it's a step in complexity, right? That one you can just throw in, connect all the fluid inputs to the front, get an RPS output at the back, and that's it. That's all you got to do. Plus you got to connect, you know, those things around, but that's fine. So yeah. But yeah, that's modular engines. Not so much in a nutshell, because this has been a lot to go over all at once. Just grab this back. So yeah, it's a lot. Modular engines are a lot. That's why they have the prefab ones. So if you go into engines here, you got large, medium, small. It also gives you a power output. I'm not entirely sure what they're measuring because it's not torque. 20,000, 60,000, 200,000. A bit. You can see it looks very intimidating, but when you think about it, we essentially are taking all of these different inputs, right? Fluid air, RPS out, coolant A, coolant B, temperature, fuel manifold, exhaust manifold, right? All that jazz. We're doing all the same thing, just with less control or more control over the power output. I guess one final thing before we end it off is we will just show the power output of each cylinder. I hate how it spawns it with the crankshaft facing up. It's so strange. Okay. Let's give this one last try. Without any runaway engines, you can see for like all practical purposes, the throttle is like near 0. For this one, just to idle, you can see 47, 34, 3.9. So this one gained 5 torque, this one gained 0.3 torque, and this one lost 7 torque from being turned on. And of course, if you multiply that by 4 for having a cylinder on all 4 sides, and just for good old comparison's sake, we will also grab the small, medium, and large engine and stuff a torque meter on each of their RPS outputs. You can see each of these engines has a slightly different spot depending on their modeling. But I believe if we just spawn them in like that, they should also give us a torque reading without them having to be running. So you can see this one has a torque of 101. This one has a torque of 31, and this one has a torque of 11. So in comparison, it takes about 3 of these cylinders here to make one of these engines. Takes about less than 1 of these cylinders to make one of those engines in comparable torque. And with this one, it takes a little over 2 of these to make one of those with 101. Of course, that's assuming that they don't lose any torque when they're started. So that's everything. That's engines. Engines in a nutshell. This is like the greatest thing ever that I've done that. There we go. And there we go. And that's all of the modular engine parts. Goodbye.